Assalamu alaikum everyone. Today we will cover the third lecture on the topic integration of further Peer 2 of Cambridge Further Maths. Here we will cover this topic today, integration with suitable substitution. It's a very important concept, guys. So please uh, do listen to what I say and try to apply those techniques while solving the sums. These are some formulae that you will see in the booklet given, so you don't need to memorize this. And this one is not given in the booklet because, what is the reason? Because you learned it in your P3. You learned how to get 1 over a squared minus a x squared. You learned this actually, integration of a squared plus x squared 1 over. If I integrate this, I get 1 by a tan inverse x by a. And similarly, if you have 1 over a squared minus x squared in place of plus, then it would be tan simply, and no 1 by a. So try to memorize this, guys. And these are the formulae that will be given in your booklet. Now, how to select the substitution formula to do the integration? You did integration by using substitution method in your P3 syllabus of general maths. Here, we will do the same thing, but the difference is in most cases, the substitution formula won't be given, but there is a technique that I will teach you so that you can guess or you can take the substitution formula by yourself. Now, I will discuss all four sums here one by one. First of all, I will teach you how to guess the formula. Now, let us check. This is the first one. The first one is root over 1 minus 4 squared. That means it is of the format root over a squared minus x squared. Now, look at this. Root over a squared minus x squared is matches with this. It is in the denominator, no problem, but look at the structure. It matches with this. So your substitution formula will be a sine theta or a sine x. And this one, root over x squared minus x squared, a squared, it is of this form. Now you can check it matches with this. So the substitution formula would be a cos. This is how I guess. And it works 100% of the times. Now, here, the power is 3 by 2. I can guess that this is root over a squared minus x squared. Now, root over a squared minus x squared, that means it matches with this. That means substitution formula would be a sine of theta. Now, come to the fourth one. Here you have root over a squared minus x squared. That means root over a squared minus x squared is a sine. Now, I will teach you another thing here, that how to get the a. Very simple, guys. Just take the value under the square root and equate that one to 0. You will get the value of x. Very simple. Now, we will do one by one. Let us start with the first one. I'll get all the a's first, how to get the values of a. So let us check how to get the values of a here. First of all, 1 minus 4x squared is equal to 0. So x is equal to half. I'll take only the positive one, no negative one. Now, because in the formula, this a, all of this a are positive. Now, this one is equal to 0. That means x is equal to 3. Now, this one is equal to 0. X is equal to 2 by 3. Now, this one is equal to 0. X is equal to half. So, I have got the values of a for all the sums here. Now, if I guess, now again, this is root over a squared minus x squared. So, it matches with this. So, it would be a sine, x is equal to a sine theta. And a is half. And what is the u? U is my substitution, the term that I will substitute to. So I am taking, these are all x's, I will take them to all u's. That is why I have taken u. Now look at this, root over x square minus a square. So root over x square minus x square matches with this. So it would be a cos inverse u. Now what is the a here? 3. So 3 cos u. Now look at this. Root over a squared minus x squared. Root over a squared minus x squared is sine inverse. So it would be a sine u. What is the a here? 2 by 3. So 2 by 3 sine u. Now look at this. A is half and this is root over a squared minus x squared form. So a squared minus x squared root over, that means sine inverse. So it would be half sine u. This is sorry, I have made a mistake in explaining. This is root over x squared minus a squared. So root over x squared minus a squared means it matches with this. So it would be a cos u. So a is half, so half cos u. So I hope you have understood how I take the substitution formula by guessing from the booklet. It's very easy, guys. Don't forget. Now, let us move with, I will now do all 4 sums here in today's lecture. That will clarify all your concepts regarding this. Now, let us start with this. I already discussed why I have taken this substitution formula. Now, let us proceed with this. So, root over, this is x is equal to half sine u. Now, I will substitute all x's here with u's. That means I am expressing this one first in root over. This is root over a squared minus x squared dx. Then it would be easy for me. X is equal to this. And now you have to do all the tasks that you did in your P3 integration by substitution topic. Now x is equal to half sin u, dx is equal to half cos u. Now substitute here. First of all, root over 1 by 4 minus x squared is 1 by 4 sine squared u, and dx is half cos u du. Now this is, if I take 1 by 4 as common and take outside of the square root, it would be half, and 1 minus sine squared is cos squared. So it would be cos here, half cos, and half cos is, so 1 by 4 integration of cos squared du. Now, can you remember how to integrate cos squared? You have to express that one in 1 plus cos twice x, or 2u. So 1 plus cos 2u du. This, how to integrate this expression, cos square sine square, we learned it in P3. So 1 plus cos 2u, now I can integrate. If I integrate 1, it would be u. If I integrate cos, it would be minus sine and divided by 2. So half sine 2u. Sorry, it's not minus, I beg your pardon. If I integrate cos, it is sine. If I integrate sine, it is minus cos. As I always teach you, sine follows the sine. Okay. Now, this is plus c. Now, I can write u. I have to write down my answer in terms of x. So, this is very important that you don't forget to express your final answer in terms of x. Otherwise, marks will be deducted, guys. So, from here, if I tell you what is u is equal to, from here you can understand that sine u is equal to twice x. Now u is equal to sine inverse twice x. That is why I have written here sine inverse twice x. Now half sine twice u. So it would be, if I can write sine twice u as 2 sine cos. Now I can form a triangle here, sine inverse twice x. Half into 2. If I form a triangle with this, sine u is equal to twice x. That means opposite is twice x and hypotenuse is 1. So adjacent would be root over 1 minus 4x squared. So sine u is twice x and cos u is root over 1 minus x squared. Now I can express like this. All of them are in terms of x, and finally a c here. So this is all the workings here, guys. Hope you have understood that one. Now let us move to the second sum here. I have already explained how I took this substitution formula. Now my task is to get the different dx and du here. Dx is equal to, if I differentiate cos, it would be sine u. So 3 sine u du. Now root over x squared minus 9, that is x squared is 9 cos square. So I have taken 9 out of the square root sign. So it is 3 here. So it would be 1 cos square minus 1. And dx is 3 sin u du. Now, cos square u minus 1 is sin squared. Now, it is like this. If I simplify, I'll get this. Now, you know that if I want to integrate sin square, I can write in double angle comparable to the double angle formula, similar to the double angle formula. Sin squared 2u can be written as cos 2u minus 1 du. You know this from the identity that we learned in hyperbolic function chapter. Now, if I integrate this, so it would be sin 2u, half sin 2u. And if I integrate 1, it would be u plus c. So this is our answer here. Now, this is not the answer, actually. I have to express in terms of x. Now, I will try to expand sin 2u, and I will try to express sin 2u in terms of x. Let us do that, guys. First of all, sin 2u is equal to 2 sin u cos u. Now, sin u can be written as root over cos square minus 1 and then cos u. Now, you know that cos u is x by 3. You just put the values here. 2 root over x squared by 9 minus 1 and cos u is x by 3. Now, if I simplify this, I'll get this. Now, you just put the values here. This is the expression, and then plus c. That's it. U is equal to x by 3 cos inverse x by 3. Now, this is your answer. So don't forget to express your final answer in terms of the given variable, that is in terms of x in this case. Now, let us move to the third sum, guys. The substitution formula was this, and we know how we got that. Now, dx is equal to 2 by 3 cos u du. Now, as this is definite integral, don't forget to change the limits, upper limit and lower limit. This is the limit for x. And when you have expressed all of them in du, it would be in terms of u's. So I have substituted here the values 4 minus 4 sin squared from here. And then 2 by 3 dx is 2 by 3 cos u du. So the limits are given. Now the limits are, as you have du here, so limits should be of u. As you have dx here, limits should be of x. So don't forget to change the limits, guys. Now I have to simplify. If I take 4 common, then it would be like this, and I'm getting this sec squared u. Now you know how to integrate sec squared, right? If I integrate sec squared, I'll get tan. Now it would be tan u. Limits are here. Now put the limits. You don't need to change now to x's because you have the limits of u. So you don't need to go back to x's again for just we did in indefinite integrals. Now you just put the values here, limits, upper limit and the lower limit, and then use the calculator to get the final answer. That's it. Exact value here. So this is the sum number 3 that we were planning to discuss in this class today. Now let us move to the number 4. That's a very important form of integration, guys. Can you remember that you did improper integrals in P1? When we call an improper integral, if one of the limit is infinity, which is not here the case, or if we put the value here, one of them can make the denominator 0, like half. If I put half here, the denominator becomes 0. So this is definitely an improper integral. It is improper integral as the integrand. This is called integrand, as the integrand is undefined because the denominator is becoming 0. When x is equal to 0.5. Now, I have to do like this. The concept were taught in P1. The value that makes it infinity take this one as a and then do the integration. And then complete the integration, guys. So dx is equal to half sine u. Now you can put the values here, substitute it. X cubed is equal to 1 by cos cubed x, and root over 4x squared minus 1 gives you this. And dx is half sine u. That means now if I integrate this one, first of all, I have to simplify, then I can go for the integration. So after simplification, you are getting this. You're getting this. Now, I just taught you how to integrate sine cubed. Now, it is the similar way of integrating the cos cube. So express this one in sine. Now, you will apply the function times derivative here. If I integrate this, I'll get sine u. And if I integrate this by using the product rule of, by using the function times derivative form, that means this one to the power 3 by 3. So this is our integration here. Now you can see that I didn't put the limits here. I have finished the integration. Now I'll put the limits. So this is my integration. Now I'll put the limits here. If I put 1, if I put, this is sine u. I have expressed sine u in terms of x because cos u is twice x here. Cos u is twice x here. So I have expressed sine u in terms of x. So I am expressing in terms of x, and then I'm putting the values of x because I do not know what will be the values of u in this case, because if I try to substitute the limits, if I try to substitute the limit of x with the limits of u, it would become very, very complicated. So what I am doing here, I'm converting the u's in x's, and then I will put the limits of x here. So this is sine u plus 1/3 of this to the power 3. And then you just put the value. If I put 1, I'm getting this. If I put a, then I'm getting this. Now, I have put the values here. Now, as it is improper integral, that means I have to put the value of a now. If a tends to 0.5, now if a is 0.5, that means a will be replaced by 0.5 here now. And we have to write like this because a is not exactly 0.5, but a approaches 0.5, very, very, very close to 0.5. So you have to write down in this manner. Now this is root 3 and this is root 3, then this one, and now you just put a tends to 0.5. And then if you replace a with 0.5, you will get this value. Now, guys, you can have a bit of understanding that we have seen so far this all of these integrations in this lecture. So do practice all the sums that I showed in the class again, and then start practicing the exercises. So this is the end of the lecture, guys. Thank you. Assalamu alaikum.